Welcome to Engadget Tomorrow. I'm Imran Sheikh, and this is where you get to hear about tomorrow today. Today we're talking about why a Blue Origin rocket engine exploded during testing, and researchers found evidence of organic matter on Mars. Let's start with a bang. Jeff Bezos' Blue Origin is still running into technical problems. The company has confirmed that a BE-4 engine exploded roughly 10 seconds into a firing test in Texas on June 30th. No one was hurt during the incident, but CNBC understands the engine was supposed to be sent to United Launch Alliance for use in its second Vulcan rocket flight. An investigation is still underway. Blue Origin says it has a proximate cause for the explosion and is working on unspecified remedial actions. And according to a spokesperson for the company, will keep testing rockets and expects to meet its customers' engine demands. The explosion comes several months after a New Shepard rocket failure that was ultimately pinned on a bad engine nozzle. ULA has had its own share of trouble. A rocket's upper stage exploded in March, prompting an investigation and fixes that include thicker steel walls on the stage. However much the setback is affecting Blue Origin's production levels, it's not good news for a company whose business revolves around engines. ULA needs 2 BE-4 engines for every Vulcan rocket, while Blue Origin's upcoming New Glenn needs 7. Both vehicles will be crucial for space exploration missions, as well as Amazon's Project Kuiper broadband satellites. Blue Origin's private spaceflight competitors have had their own problems. SpaceX is still struggling to put Starship into orbit, and Virgin Galactic only just completed its first commercial flight. The flawed engine won't necessarily represent a major hurdle then, even if it does force the company to adjust its schedule. Let's move on to matters on Mars. Researchers found evidence of organic matter on Mars, but they need to bring the materials back to Earth to confirm their origin. The Perseverance rover found evidence of organic compounds in the Jezero crater on Mars. Although this isn't the smoking gun proving once and for all that Mars once hosted life, these compounds could have also developed in non-biological ways. The results hint at surprisingly complex organic conditions for the key building blocks for life on Earth's neighbor. The study was published in Nature. The Perseverance rover is the first to explore the Jezero crater and has been investigating the area since February 2021. Researchers believe the basin once housed an ancient lake, including a delta from a river that once flowed into it. It's one of the most likely regions to reveal leftover signs of life on Mars. Organic molecules, like those observed in Jezero crater, contain carbon and often hydrogen atoms. They're the core components of life as we know it on Earth, although they can also develop abiologically. The paper co-author Joseph Rizal Hollis, a postdoctoral fellow at London's Natural History Museum, told Newsweek they are an exciting clue for astrobiologists since they are often thought of as building blocks of life. Importantly, they can be created by processes not related to life as we know it, and so organic molecules are not evidence of life on their own without sufficient extra evidence that cannot be explained by non-biological or abiotic processes. The rover observed the compounds using an instrument, the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or SHERLOC, that maps organic molecules and minerals on rock surfaces. Significantly, it found organic materials in all 10 targets it observed on the crater floor. Co-author Joseph Rizal Hollis, a London-based astrobiologist, told Gizmodo, "Our results support observations by previous robotic missions to Mars that the red planet was once rich in organic material, compounds made primarily of carbon and hydrogen, and that some of that organic material can still be detected billions of years later." Each detection, each observation gives us a little bit more information that brings us closer to understanding the history of Mars and whether it could have supported life in the past. Now that the researchers have observed the molecules, they'll need a better look at them in Earthbound labs to draw further conclusions about their origins. The authors wrote, if these samples are returned to terrestrial laboratories, a more diverse suite of tools can be used to study the samples, including at higher spatial resolution and with much greater specificity and sensitivity. They'll have to wait for the Mars Sample Return mission, which isn't expected to launch from Earth until at least the late 2020s. Still, the trip should be worth the wait. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributors Will Shanklin and John Fingus and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.